the point is we are using the sunlight heat. We are using the sunlight heat to heat up this water. Okay. So the sunlight radiation is coming, right? EM waves, they come and hit. So first radiation comes, and now we have to collect this heat. So how do we do it? We we take we take blackened metal sheets. Now black is a good absorber. It's a very good absorbing material, absorbing radiation. Okay. Then the copper is a very good conductor. Once it gets hot, it's black, so it absorbs and it gets hot. It conducts. It's a very good conductor. I showed you. It conducts to the water inside. There's water flowing inside. Then there is an insulating. So even if it's get heated, so the heat shouldn't run away. So it's got an insulating material to stop. So these three: one, black metal black sheeting to absorb radiation, and copper black to absorb. Copper, second, copper is a very good conductor, so it conducts heat. Three, it's got insulating material so that it doesn't heat doesn't escape. Four, the trapped air avoids heat loss through convection. The air can't go out, it's trapped. And there's a something called the greenhouse effect. So it can't come out. The glass here uh, is like a greenhouse. It doesn't let the heat go out. So all there are five features. One, two, glass greenhouse effect. It doesn't allow the heat to escape. Three, copper is a good conductor, so it gives to water. Four, insulating material, so doesn't let the heat go out. Five, the trapped air does no convection possible, no heat loss. The air can't run out. Six, five are enough there. So these are. So let me see what are the answers. He says copper is a good conductor, black is a good absorber, bad reflector that I missed. It doesn't reflect also. So this is important. It absorbs and keeps it and doesn't. Yeah, it doesn't reflect. Some materials will absorb and also reflect. So they have to take 50% absorption, 50%. They're taking most of it and bad reflector. So this is very important. This is important. Good conductor of heat. Okay. And insulating material will reduce heat loss, conduction away from pipes that I said. And air travel reduces, prevents convection, warm air being blown away, and greenhouse effect. So this is IR is infrared radiation. You see, greenhouse is like if you ever park a car or anything which has got glass windows, so the heat can come in, but it can't go out. Glass doesn't allow the heat to go out because the heat can come in because these are shorter wavelengths. So they have a high energy, so the glass can't stop them. But once the inside of the car is heated up, the seat, they start radiating, but they are long wavelengths. So the long wavelength are low energy. The glass can stop them. So what happens is the car inside gets very hot. So you have to, if you sit in a car, you have to open the windows in a hot summer day because you can't directly sit in a car. It's very hot. So the glass will always let stop entrap the heat. So that's what the glass. That's how they use it in the greenhouses in deserts. That was the concept in which they would use these greenhouses to in deserts. In Israel, they do these to grow plants. It's a desert area, so the sun's thermal radiation passes easily into, but unless you leave a door or window open, the heat cannot escape. That's why plants can grow in deserts because at night it's very cold. The plants die, but they entrap the heat, and so they can survive and they can grow.